So I want to talk about the things that we're going to keep track of when we look at the entire cardiac cycle, all of the events that take place in one heartbeat. And we're going to start it out, assuming I can pick the right color. We're going to start it out with, you'll notice that this is an awesome visual because it shows us the anatomy of one heartbeat. It shows us what the chambers of the heart are actually doing. And remember, we've got that little thin thread of autorhythmic tissue going through the whole heart, and that coordinates beating. But most of the heart is made of contractile muscle tissue. 99% of it is contractile muscle tissue. So all of this pinkish stuff you see around the edges, that's all contractile stuff with a little thread of autorhythmic cells going through there. So as always, when you're dealing with a cycle, you're going to have a sort of arbitrary start point. And that start point, it's an easy start point if you think of everything being relaxed and the atria are filling. The atria haven't yet contracted. We're going to look at volumes and pressures involved in atria and ventricles. We're going to look at electricity, like how the electrical conduction system actually coordinates all of that contraction. We're going to look at heart sounds, which are caused by the contraction, the turbulence that results from blood attempting to flow backwards and valves shutting in response to that effort to flow backwards. And we'll talk about how that exactly works to create the sounds that we hear in the heartbeat. And then we're also going to look at the EKG or the ECG, the electrocardiogram, which is a sum of all the electrical activity that's happening in the heart. So we're going to coordinate all of these different parts and pieces. So I'm going to write them down for you really fast. We're going to talk about the ECG, and EKG is like German, and it's easier to hear EKG. You don't get it mixed up with things like EEG, which is looking at brain waves. So we'll often call it an EKG, and we'll spell it ECG, which, of course, makes things super easy and clear, right? And that's just a sum of all the electrical activity. We're going to look at pressure and volume changes, and then we're going to look at heart sounds. And so spend just a second before we get rolling to look at this little visual right here and see if you can figure out the events that are happening and where you think blood is going from one place to the next and why blood is moving from one place to the next. This image comes from the OpenStax A&P text. It is a free and open text that everybody has access to. Just go search OpenStax Anatomy and Physiology textbook, and you have access to all these Creative Commons licensed images. All right. The best place to summarize all the things we're going to look at is a diagram from old boy named, I forgot what his first name is, but in just a second I'm going to come back and tell you his first name. But his last name is Wigger, and he came up with the Wigger's diagram. I'll be right back to tell you about it.